Hello everyone. Today I'll show you how to do a 3D model of a mastoid or temporal bone and print it. First, let's start with a CT scan. You open it ITK Snap. It has this special feature where you can extract a 3D model. So the first thing to do is to create this bounding box around the temporal bone. You make sure that all the temporal bone is inside that box in all three planes, axial, coronal, and sagittal. Once you are satisfied with this, you will be able to proceed to the next step. It is important to make sure that you have all you need in that box. The reason you want to do that is it makes it faster for the program to be able to select the bone, which is what you want to do in that case. If you select more of it, it will take just more time and more resources and be more taxing on your computer. So this is why it's helpful to really just select what you need. Now, once you're satisfied with that, you move on to the next step. We're going to use a method called thresholding, where you essentially pick the threshold, which is essentially the brightness of the bone, essentially. You will play with the values a little bit until you're satisfied that you can see only the bone and no soft tissue or something else. The other thing to do also is you want to make sure that you select which bones are going to be highlighted or taken into the 3D model, because the ossicles are small and typically with the program they won't be selected because they're not connected to the rest, or at least their connection is very small. See how in this case the program automatically selected just the ossicle and didn't select any of the other bones around it. So now we're going to have to select the rest of the bone. This is there of the oval window. You can see here the stay piece. Because it's very small, it did not get selected. So we'll have to do that manually later. Now you can see that this is only the malleus, probably part of the head of the incus. So the next step now is to select all of the bone. To do that, once you've had selected the right threshold, you put in these bubbles, and from there they will expand to include just the white part, which in this case would be the temporal bone. Notice how part of the bone here is actually marrow, and it will look like there is just a cavity here, but that's just solid bone with marrow inside. So you do have to play with the parameters, smoothing and others, but that's something to discuss in a dedicated tutorial of ITK Snap, which is not the goal of this particular video. It will run the algorithm for a while, and then you just verify. And this is the part I was talking about. This is marrow, it's bone. It looks like you would have like some pincer here, but it won't matter because that's not the part you'll be working with. Notice how the trabeculae of the mastoid are not getting red, which means they're not included into your 3D model. And that's because the algorithm has trouble going into these narrow spaces. Now that we've paused the program a bit and looking at the rough model. You can see this is, for example, the sigmoid sinus, but it's very thin in areas. And so the program doesn't fill these. Same with the tegmen here. So we'll have to go and fill these manually. But roughly, it looks pretty good. Again, I'm checking to see if we can see the ossicles, and they're not too good for now. So we'll have also to add them manually. So once we have this rough shape, I'm going to finish it. Update. Looks pretty decent. We're going to go and make it perfect. I will make this axial one just much bigger. We'll zoom in into the area of interest, and then we'll start working. So I just use a brush, and then we will paint these areas. This is the tedious part about doing this. This video actually has been accelerated like 4 or 5 times. And this is how you do it. Just fill in everything that's white. That's supposed to be red now. The white is the bone. Black is air, and the gray is the brain. Also, some of the gray in the mastoid is just fluid. That patient has some mastoid opacification. I'm sure there are ways to do that more efficiently, or maybe there are programs that are better than this. However, ITK Snap has the huge benefit of being, number one, open source, number two, it's free. Free is always good. So every time I fill in some of these, I will update the 3D model and I will check if I'm plugging these holes or not. There are multiple ways of doing this. Now I'm going to focus on the ossicles, for example, just finish them and be sure I captured all of it into my model. It is obviously very important that you know your anatomy very well, not just filling in blindly. The nice thing about this particular CT scan is it dedicates CT of the mastoid. So it is high resolution. And the fact that I know how the stapes should look like and which position allows me to do this. So now we look at the updated model. It actually looks reasonable. The stapes is not that fat, but it will do for this. It's important just when drilling the mastoid that you're able to see these landmarks. Since we're not doing any otosclerosis surgery on that resin temporal bone, it won't matter. Now the next thing that I'm looking at is actually the stylomystoid foramen and the facial nerve path into the mastoid. The thing I'm looking at here is that stylomystoid foramen doesn't look very patent to me. And so I want to make sure that I did not by mistake obliterate that. And so I can use the brush again manually to open up that foramen and the fallopian canal for the facial nerve. Now I did that initially with the red mask. it is a bit too opaque, and so I might be missing some of this gray-white contrast. And so the next thing to do, I think, will be to reduce that opacity so that I can see a bit better. I think will be more helpful, because right now it looks better on the 3D model, but I'm not convinced I got everything. So we'll do that. And that will also allow me to fix the cochlea as well as the semicircular canals. Because these are very small holes, sometimes the program or the algorithm will select them and obliterate these holes. So after I've positioned myself properly, I start finessing and really fine-tuning everything that should not be highlighted in red. And so this will be a canal in the 3D model. I'll also use that opportunity to also fix the semicircular canals as well as the cochlea. Again, this is pretty tedious, but this will allow for a much more anatomically representative 3D model. Much better now. So the next step now is going to fix the trabeculae of the mastoid. There is no silver bullet here. You have to go slice by slice and paint them in. Eventually at that level, I noticed that these are the semicircular canals. I lied earlier, I didn't fix them when I fixed the facial nerve. And since they were obliterated, I just opened them up, them and the cochlea. Now I can tell you it is pretty boring, so you could skip that, but you could also just keep watching. But you won't get extra points or bonus points. Sorry. That's also the level where I realize that this is where I have my opening over the sigmoid sinus. As you can see, the bone covering the sigmoid sinus is pretty thin. So I will fix that now. The other thing I noticed is if you use a 1 pixel width brush, it won't be captured into the 3D model. So you have to use 2 pixel width. I'm saying that now because I noticed once I was done, the places I used a 1 pixel width brush because I thought I was being precise were still not showing on the 3D model. So that's a pro tip for you. Alright, at this point I'm done, I think, but the model still shows holes. So I move into another plane. So in the sagittal plane I notice there are still some holes. So at this point I'll just keep all 3 views so I can work on one and then check it in real time. It's much improved from the beginning, but there are still some imperfections. very satisfying to see them being fixed quickly and nicely. Now let's check into the coronal plane. I think at the level of the sigmoid sinus, I saw some holes. And I'm sorry, I meant the sagittal plane still. And I think now it's almost done. Last thing probably to check is to look at the different foramen. I think the carotid artery needs some fine-tuning as well. The way you check for that is you look at that model, you turn and twist it around. In that particular case, I noticed the carotid canal was not perfect, and so I've selected the parts that were not selected yet at the level of the station tube here, and now it looks better. Alright, so now it's time to save this. In that program there are two things to save. There's saving the segmentation, so you can find it another time, and then you also have to export the 3D model. Here I am fumbling to see where is the export. Finally found it. It's called export as mesh, surface mesh. And that's your export is complete. Now the next step is to take it into Meshlab or any other 3D program. It shows all the layer lines, so I apply a Laplacian blur and it gets rid of them. It smooths the 3D model. And now we save it. Save it as right mastoid smooth. Next step, open up your 3D printer slicer. First you check and make sure it looks okay. Here are my ossicles. You want to support that model, and don't use support inside the model, just coming from the platform on the model. And since I can print 6 at a time, that's what I'm gonna do. First, check the settings of your printer. These are the settings I've already selected before. They work for the resin that I've picked. I checked that the slicing looks okay. Now, as I said, I'm gonna print 6 of them. But I'm gonna do something different also. I said don't put in support on the inside, except for the ossicles. I'm gonna try on 3 of them. I just put 2 small supports on the inside. I think will help them be printed better. So I did that on 3 of them. And once we're satisfied with the placement, making sure nothing is sticking out of the build plate, you just send it to the printer and you print. Here we go. Obviously, before printing, you need to fill your printer with resin. So I use that specific resin. It's Siraya Tech. I've tried a different resin as well, but it didn't work as well. This one is white, just like bone, a bit too white. You also need to wear gloves and wear a respirator because it smells really bad. That's the build plate going into the resin. And it took about 2 hours, and the final result, nicely printed. So now you have to take them out and put them into their alcohol bath, 95% ethyl alcohol. Again, respirator, gloves, give them a good wash. Some resins are water washable. I've tried them, but they weren't as good as this one. So for now, I'm sticking to the alcohol washed resin. The next step now is to take them off the build plate and then remove the support. After they've dried, you have to cure them into UV light. I used about 10 minutes. That's the final result. And I confirmed that using support allows the ossicle to be printed perfectly. And the ones that had not used support, they did print, but they weren't as long and as nicely defined as in this one. Now we'll have to do more post-processing. I used some acrylic to paint the sigmoid sinus in blue. I'll show you at the end why it's important. It allows you to see it when you're drilling. Same for the dura. Use some metallic acrylic in pink and then some yellow for the facial nerve. And I fill it with plastic filament as well. It is now ready to be drilled. This is being drilled at home without a suction and without water. It does make a mess, but if you have a nice box where you can put in this temporal bone holder that's also 3D printed, you can train at home. You can clearly see the mastoid air cells. And after I've cleaned it with water, you can see how it actually looks pretty nice. Now, if you have access to a real temporal bone lab with suction and with irrigation, this is how it looks like being drilled. Looks pretty similar to the real deal. Even the resin dust looks like bone dust. And now for the final result. This is why you paint them, because you can see the blue and the red by transparency. And that's something to expect during real surgery, where you'll see the sigmoid sinus by transparency. In conclusion, this is the whole process from start to finish. You can take a patient CT scan, you can make a 3D model using ITK Snap, smooth that model in Meshlab, print it in your preferred slicer. I think that resin printers are better than filament printers. I've tried both and I have a video about that. The only problem with resin is that it is a bit more expensive than the filament and it's toxic. So you do have to have some setup with respirator and mask and ethanol to clean it. So it's a bit less straightforward than the filament printers, but it gives you much better quality, and the haptic feedback from drilling resin is really close to the bone. However, the plastic is cheaper. The haptic feedback is not the same. It is decent, but resin is just much better. So I would recommend that if you intend to train on mastoidectomies or any other ear surgery. Now that same process can be used for other than creating models for ear surgery. It can also be used to help in designing and planning mandibular reconstruction or maxillary reconstructions, and that will be the subject for another video. So thank you for watching. I hope that you learned something new, and stay tuned for another video about reconstruction this time.